Alright folks, this is going to be a quick video about roots. Well, we talked about why square roots are irrational, but we weren't pretty particularly formal about what a square root means. So what is an nth root? That's what we're going to talk about. And we're also going to talk about how many nth roots exist for each, let's say a in the integers. And the third thing we're going to talk about is exponential notation. For roots. Alright, so let's talk about what is an nth root. So, let's let a be. In fact, we can pick a real number. Doesn't matter what real number we say. Then the nth root of a is, or let's, maybe not the, let's change the to a, and I'll explain what I mean by that in a second. An nth root of a is a solution to the equation x to the n equals a. So let's see a couple of examples, and you kind of see why I said an nth root and not the nth root. So let's let n equal 2, so we're talking about square roots, and let's say a is, I don't know, let's do 25. Well, the nth root of 25, in fact, let's put in some notation for an nth root. So an nth root of a, you can write as like this. So you put a square root sign with a little n up there. And if there's no n, it's assumed to be 2. All right. So here we have the square root of 25. Well, what does that mean? So that's a solution to the equation x squared equals 25. So what number, when I multiply it by itself, gives me 25? Well, 5 does it. 5 times 5 is 25. 5 squared is 25. But also, negative 5 times negative 5 is positive 25. A negative times a negative is a positive. So, the solutions to x squared equals 25 are the numbers 5 and negative 5. Now, we want to come up with a nice way of writing this. So, this symbol here, this kind of nth root symbol, we always reserve this to mean the positive solution to x squared equals 25. So we can say the solutions are the square root of 25 and a negative the square root of 25. So whenever we write that square root symbol, we mean the positive solution. That'll be the same with any nth root. Let's look at another example. Let's look at, let's say n is 3 and a is 8. Then the cube root of 8 And I do mean the, because there's going to be only one answer to this. So that's the solution to the equation x to the cube equals 8. And my answer is, well, what number when I multiply it by itself 3 times gives me 8? Well, it's 2. What about negative 2? Well, negative 2 doesn't work because I have 3 negatives, so if I multiply those together, I get a negative. So that would give me negative 8. So here, I have one solution. The square with the cube root of 8 is 2. And I'll just make a note, is that this symbol is reserved for the positive solution if it exists. I'll explain what I mean by that, by some examples. So, if I write the square root of 49, that is 7. Even though x squared equals 49 has 2 solutions, 7 and minus 7, the symbol here means the positive solution, so it's going to be 7. Something like the cube root of 27 is 3, but if I want to write the cube root of negative 27, because, well, there is a solution to that. Negative 3 times negative 3 times negative 3 is negative 27. So my answer is negative 3 in this case, since no positive solution exists. Okay, so we talked about what a square root and a cube root and any nth root is. In fact, let's do one more, maybe. We'll talk about an nth root that's not squared or cubed. Let's do I don't know, n equals 5 and a is 12. Then, well, the solution to the equation x to the 5th equals 12. Well, it turns out, and I guess you guys can see this from what we talked about last lecture, is that this is going to be an irrational number. So I know that the 5th root of 12 is irrational. See, there's no really nice way of writing it besides just saying it is the 5th root of 12. So this is fine. You could use a calculator to kind of give you a decimal approximation of it. But remember, the decimal will have no pattern, no repeating pattern, I should say. So this is the best way we can write it. We can just leave it like that. So now a quick note on how many roots exist. For some n and some a. So n is, that is your natural number, and a is, let's just do integers for now. Okay. So, it turns out that if n is even, then, well, if a is greater than 0, then there are 2 nth roots. Let me write them down. They are and this guy is called the principal nth root of a, and it's negative. But if a is less than 0, then there are no nth roots. And I'll explain why that's true in a second after I write down every case here. And thirdly, well, we talked about when a was greater than 0, a was less than 0. If a equals 0, then there is one nth root, and that's really easy. It is just, of course, 0. So the nth root of a equals 0. So let's look at why. Okay. So what does the nth root of a mean? Well, it's a solution to the equation x to the n equals a. But remember, n is even, so maybe instead of writing, or no, I'll keep writing n, but just keep in mind that that's an even number. So if there's a solution, then it's going to look like this. It's going to look like x times x times x times x all the way to times x equals a. So this is n copies of x. But remember, n is even, so you can pair them up here. So, what is that telling us? Well, that's telling us if we want, we could also put -1 times x in here for these and get the same answer. Equals a. So pairing them up like that. Because -1 times x times -1 times x is x squared, which is the same as x times x. So each of these guys gives us an x squared. So it looks like that -1 times x and x give us the same solution, which is great. Or they both solve the equation, I should say. So well, what does that mean? So if a solution exists, there are two of them except 0. Since positive 0 equals -0. There's no sign to 0. So that's the only special case. That's why there's only one solution when a equals 0. So, when do solutions exist? Well, note that every pair here is positive. Since you're squaring something, and if it's not 0, it's positive. So you get a bunch of positive things multiplied together. Same on this side. All these pairs give you something squared, and something squared is always positive. So, what does that tell us? Well, the left-hand side is always, let's say, non-negative, because it could be 0. Well, that means, thus, if a is less than 0, so if the right-hand side is negative, then there is no solution. Since, well, you can never have a bunch of positive numbers multiplied together to give you something negative. So if the right-hand side, if this is negative, there's no solution. All right, so that's great. The next case is when n is odd. Well, when n is odd, well, it's really easy. There's only one case. There's always one root of any integer a. So that's pretty easy. And that's since, well, if we have x to the n equals a, well, we can't pair them off anymore because there's one left over. So we'll try times x times x times x. So we get two numbers multiplied together. This is definitely going to be positive. This is definitely going to be positive. But we don't know what this is. If x is positive, then our side here is positive. If x is negative, then our side here is negative. So this equals a. So the left-hand side can be positive or negative, and the right-hand side can be positive or negative. So there is only one solution for every a, which is great. So odd roots are easy to think about since you just take it. There is one root. For even roots, there's a couple of cases. If it's positive, then there are two roots. If it's negative, there are no roots. And if it's 0, well, there's one root, and that root is 0. So let's do one quick example. Let's find all roots, or all solutions, I should say. All solutions to the equation. Let's do 3x to the 4th minus 7 equals x to the 4th plus 1. That will do. Okay. Well, let's go ahead and let's solve this so that it looks like x to the something equals a number. Okay. So, what do we get? All right. So we'll subtract x to the 4th from both sides. And that will give us all our x to the 4th on the left-hand side. Then let's add 7 to both sides. So we have 2x to the 4th on the left-hand side, and on the right-hand side, 1 plus 7 is 8. We'll divide both sides by 2, and we get x to the 4th equals 8. Okay. Well, 8 is 2 times 2 times 2, so 2 cubed. Well, we know we want to take a 4th root, but 3 isn't a factor of 4, so we know that it's going to be an irrational number, so we can't write the 4th root of 8 any nicer than just saying it. So we have to ask ourselves, well, how many roots exist? Well, 4 is even, 8 is positive, so there's going to be 2 roots. So our solutions are going to be, we'll just write it like this. X can be the 4th root of 8 and negative the 4th root of 8. Another way of writing it, if you like, is you could write plus minus the 4th root of 8. Both ways are saying the same thing. The second one's just a little more encapsulated. So a couple more quick examples. So what are the solutions to the equation x to the 6 equals negative 12? Well, we look at this. We have an even power. The answer is negative. So when we're in that situation, there are no solutions, no roots exist. And the final example I want to look at is what are the solutions to, let's do x to the 5 equals negative 12. Well, looking at this, we see that the power of x is odd. So that means there's always going to be exactly one root. So it's going to be the 5th root of whatever we're taking the 5th root of, negative 12. We don't have to worry about positives or negatives when we have an odd power. And we ask, can we simplify that? Well, we can't. 12 is 2 times 2 times 3, so we have 2 2's. 2 isn't a multiple of 5. 5 isn't a factor of 2. So this is going to be an irrational number, so it looks like we can't simplify it. We can just leave it like this. So x is the 5th root of negative 12, and that's the only solution. All right. Finally, I do want to talk about roots and exponential notation. Okay, well, let's think about this. When we come up with a new concept, it's a good idea to kind of explore what's happening here. So, I know that the square root of 2 times the square root of 2 equals, of course, 2. That's what the definition of the square root is. When you multiply that number by itself, you get 2. Okay, well, let's see if we wanted to represent the square root of 2 by some exponent. So let's call it 2 to the x. So I got to figure out what x is. What x would represent the square root of 2? So it satisfies the other rules that we know already and we want to keep using. So 2 to the x times 2 to the x, we have to figure out what x is to mean the square root of 2. But I know 2 is the same as 2 to the 1. So I know the rules for exponents, so if I add up the exponents, I should get the simplified version of it. So x plus x equals 1. So 2x equals 1. Divide both sides by 2. We get x equals a half. So the square root of 2 is the same as 2 to the 1/2. And in general, this argument can hold for anything. So in general, we have that the nth root of a is the same thing as a to the 1 over n. All right, and remember, we have this other rule that says if we have a to the b all to the c, that's the same as a to the b times c. Well, we can do that with fractions as well. So if we have something along the lines of a to the 1 over n to the power m, well, this is the same as a to the 1 over n times m, which is a to the m over n. You can think of m, of course, as m over 1, and then multiply fractions. But we could split that up another way as well. So if you like, we could split it up as a to the m times 1 over n, which is the same thing as a to the m to the 1 over n. So what we're saying here is you can kind of swap the place of powers and roots, no problem, and you can combine that notation into one fraction, which is really cool. So let's do a quick example to see how this works. So let's simplify the following. Let's do 8a to the 2/3. Okay, so let's split that up, and we'll look at the a and the 8 separately. Okay, so this 8a to the 2/3 is the same as, well, 8 to the 2/3 times a to the 2/3. Remember, we can, when you have two numbers to the same exponent, you can just take each of those numbers to that exponent, which is what we did here. Great. So now, well, a to the 2/3 we can't really simplify. Maybe we could write it as either a squared and then the cube root of that, or we can write it as the cube root of a all squared. So they're the same way, the same thing, different ways of writing a to the 2/3. Either is good, or you could leave it as a to the 2/3. That's acceptable as well. But can we simplify 8 to the 2/3? So let's think about it. What would be easier? Let's explore. So our two options, I'll just do it up here. We can take the root first, so the cube root of 8, and then square it. Or we can square 8 and then take the cube root. Well, my thought here is that it's easier to take the cube root of a smaller number than it is a larger number. So maybe I want to take the cube root first. So I think this will be what we'll do first and then square it. So, well, 8 to the 1/3, the cube root of 8 is 2. Since 2 times 2 times 2 is 8. And we still need to square that, so it will be 2 squared, and then times this a to the 2/3, and 2 squared is, of course, 4. So this is 4a to the 2/3. And we ask, well, does this actually exist? Well, what if a is negative? Do we still get, can we still take a cube root? And yes, we can. Remember, with odd roots, we can take an odd root of any number we like. So a can be anything at all, and there will be an answer. If the root we were taking here instead of 3 was some even number, then we'd have to ask, well, if a was negative, then we couldn't take a square root, so that, or an even root, I should say. So the expression wouldn't make sense. But here, because the root is an odd root, in this case the third root or the cube root, everything makes sense. We're good to go.